Orange.
Yellow orange or orange, something like that, okay? Now, the purpose of this experiment is to give you an understanding of what produces color. Why are these red and why are those green? Why is this blue, etc. So color is produced by, you've heard me say this, electrons, imagine that. Chemistry is all about electrons, okay? And if the electrons in the so this is the atom is generally described that way, just to make a quick picture. We know that this is not absolutely accurate, but electrons from the low, all these electrons have different levels, and we call these levels quantum levels, or energy levels. And at rest, at room temperature, all of these electrons mind their own business. They stay where they're supposed to stay. This is called the first shell, this is the second shell. So generally the electrons stay where they are. But if we excite the atom by some method of putting in some energy, so here I'm putting in energy, which is a flame. I can put energy in like that using electricity, all right? I can actually put energy in by putting sunlight on something. You've probably seen years ago, they used to have dials on watches. You put them in the sunlight for a little while and you take them away. And you look at them in the dark and they glow in the dark because they retain the energy from the sun and then return that energy very slowly. And that's called fluorescence or phosphorescence. That's a different process than what we're doing today. But basically we're going to take these elements and we're going to put energy into them. And in so doing, what you do is the electrons get excited and they promote themselves to another level. They move from the first level to the second level. And sometimes they go right up to the third level, sometimes they go right up to the fourth level. So it depends on how much energy you put into them. So the first level can move to the second, the third, and the fourth level. This second one can move up to here, up to the third and the fourth level. So this is level number 1, this is level number 2, this is 3, this is 4. And there's other levels, of course, depending on what the elements are. Okay? So as I told you earlier, just because there's no occupants in an apartment building, it doesn't mean the apartment building doesn't exist. Every atom has got potentially an unlimited number of levels, and I can't draw this full circle, but you understand what I'm saying. So there's an unlimited number of levels that could be potentially occupied by these electrons if we put enough excitement into them. And with a fire, we're not going to do much more than put in maybe excitement to 3 or 4 levels. On the last desk over there, we have fluorescent tubes. They're the same as these tubes that you see here, except they're smaller. These are filled with mercury vapor. Mercury vapor, when excited, emits a white light. Those tubes, when excited, will emit a pale orange light, and the other one is a pink light. Okay? And I'll show you some demonstrations here where you'll see other kinds of light because we're going to excite these electrons, not with electricity, but with fire. Okay? So in the excitement of these electrons, they get promoted to a higher level. Okay? And that happens instantaneously. They jump to a higher level. And then as I take one of these metal things and I will excite it, some electrons are being excited while other electrons are relaxing. And it's in the relaxation of the electrons that they come back down. They come back down to a lower level. As they come down to a lower level, they emit light. Okay? So we always ask a question on a test. When we excite an electron, the question would be, when an electron is excited, it emits light. And is that true or false?
No.
No, it's when it relaxes, it emits light. Okay? It's when it's excited, it just absorbs energy and it moves up to a higher level. Nothing happens, and visually we see nothing. It's only when they relax back down that they will emit light. And that's happening all the time. As I put this in here, some of the atoms are actually being excited and others are being cooled down. Even though you don't see it on a microscopic level, there are actually some atoms that are cool and some atoms that are hot, depending on the flutter of the flame. All right? So let's see what happens if I test a few chemicals here. So this would be sodium chloride. This is calcium chloride, potassium chloride, barium chloride, and copper chloride. So each one is a chloride. Chloride is the second name, but they're all different cations. So we'll take a little bit of each of these. This is sodium, and I want to be able to just show you how this works. So you're going to be doing these tests yourself. So the first one is sodium, the second one is calcium. And I'm just going to line these up in the order just so we don't get confused. This is now potassium in the third. And you don't need very much of this, you just need a bit down at the bottom of the test tube. This is barium. Now, copper, if you look at copper, it's blue to begin with, so we don't need a whole lot. So this is being excited by ordinary light. It just needs a tiny amount of energy, and it's been excited, and it stays that way. If I put this into a dark room, I don't know what the color is, do I? Because there's no light. So obviously light is what we're looking at. So how it affects our eyes is really what we're trying to determine. So we're not going to worry about that. I'll take a little sample and show you the pretty color that it gives when I burn it. So this fifth one would be copper. All right. So when you're working with this, cleanliness is very important. So we'll take a cleaning solution, which is hydrochloric acid, and I'll put that in the end here. So the hydrochloric acid just serves the purpose of cleaning off my little metal wire, because I'm going to get contamination between the colors, and I don't want that to happen. So this is hydrochloric acid. You heat this up. The flame doesn't have to be crazy hot. And while it is hot, see it's still glowing hot, put it in here. And you'll hear it go sizzle. Alright, and you see the color it's not as intense as it was, sort of clean. You guys know how to blow bubbles when we were kids? I've captured a little drop in the hole. You see a little drop of the chemical in the hole? Alright? So when your kids used to blow the bubbles, we're not going to do that, we're going to heat it up. And I should see that it'll evaporate and a color will come off. So a tiny color came off, and that's because it's got contamination. So we don't see any color this time. Okay? So it's clean. So now we're going to go and we're going to pick any one of these. Which one? Let's do I like to do barium. Barium's a pretty color. So when I do the same thing, you take the tube and make sure you have a little bubble in here. And make sure you do that. Now you got to watch the first flash of color that comes. You see the color? See the color? So barium gives a kind of yellow color, but it has a little bit of a green tinge to it. Okay? Notice we have contamination on here now. See the white? So again, we go back and we'll.
So we should use the different one.
Well, don't use a different one. Just use the hydrochloric acid and burn off the color. So we're trying to get this clean. See, it's clean now. All right? So we'll go to another color here. This one's going to be number 3. This is potassium. We'll do the same thing here, make a little bubble. So a little bubble. We'll go to potassium. See the color? What was the color? What was the color? The color happens pretty quickly though, because there's only a tiny amount on the end here. Well, see, kind of purpley orange. Now, because these have a number of electrons here, depending on which level it jumps to, the higher it jumps, the more energetic the return is. It jumps up high. It's like if you jumped up here and then jumped onto the floor, you'd have a certain pain in your leg, so there's a lot of energy. If you jumped up here and then jumped down to the floor, you'd have a bigger pain in your leg. If you jumped off the top of this building, the higher you are, the more pain you you'll feel when you reach the floor, when you reach the ground. So the higher you are, the more energy there is in the drop, and therefore you're going to give a higher energy. Higher energy means very blue. Low energy means very red. So if you look at the rainbow,